Hello, everyone. Welcome to this Braga BIM edition, and welcome to Subvisual's office. It's a pleasure to have you all here. And a shout out to the guys from Armela to keep these editions of Braga BIM going. This is a great thing to keep this community alive. So thank you, guys. So yeah, as Nelson said, I'm this guy. I'm João Silva. Some people call me Silva these days. I don't know why. Yeah, my background is in software engineering. Yeah, and later on, I specialized in distributed systems, and was while I was taking my master's degree that I started learning about Erlang and Beam, and then the step to learning Elixir was really small. And was around the same time that I became interested in Web3 and blockchains and consensus algorithms, Web3 in general. And then, yeah, I think those intersections of knowledge were enough to deceive those guys from Subvisual into hiring me. Yeah, then I joined, and I think that was around that time that I felt that I was at my peak, like coding Elixir and doing stuff. Everything I was doing was with Elixir, creating new projects was with Elixir. And guess what? My first job, Node. And yeah, this is kind of me in the first couple of weeks, faking my happiness into doing my job. But yeah, and I think this was the reason that I decided to do a talk about why I keep thinking about my X or my Elixir when I'm coding other stuff. And of course, I couldn't miss the chance to use this title in a talk. Yeah. Well, I hope this will be a light talk, and I intend to tell you a bit about my experience of falling into a TypeScript and Node project when all I knew was Elixir. So yeah, bear with me. You will see a lot of TypeScript. So yeah, I'm sorry about that. Yeah, first of all, I want to give you some context about this project. Was a backend project. This backend needed to serve some data. It needed to fetch some Ethereum data from time to time and compute some things. It needs to store data, and it needed to interact with some smart contracts, do some calls, some basic stuff. So I think this would be a possible architecture for our application. It's a very simple application. We would only need to respond to requests. We would need a connection to a database, and yeah, we would need to be able to communicate with an Ethereum node. And yeah, I think this communication between our server and the Ethereum node was the reason why my ancestors chose Node and TypeScript, because yeah, we have these two great tools. First one is TypeChain, and TypeChain kind of generates all TypeScript that we need to interact with contracts. And then we have Ether.js that just offer a bunch of utilities to communicate with the blockchain like no other tool that I know of. So I kind of forgive them for choosing these technologies. So yeah, starting from the beginning and bootstrapping our project, we will use TypeScript, as I said, because yeah, it has types and it has a cool type system. Then we transpile all this to JavaScript, and we run it into Node, which is just an execution environment. And we will use Fastify as our web framework for now. So can you see it back there? It's good. Okay. So we have this native Fastify generator where we could just use to bootstrap a TypeScript and Fastify project, and generator creates a project for us and some scripts we could run. We could run this in development, like we all know, like npm run dev, and we can just run the server alone, like in production or whatever. Then we would end up with something like this. Can you see it back there? Okay. So we have our app, which is app.ts, which is our entry point to the application. Then we have our roots folder which is where our roots and controllers live. Yeah, so it follows this thing, this standard of keeping our routes into the folders, specific folders that matches our URL. So for example, this index here will have like the controller for the slash example route, so which is yeah, the standard, I think. And then we have the plugins folder that has the plugins that we could plug into our request lifecycle. They are kind of the same as the plugs in Elixir, kind of, but not really the same. Well, back to Elixir. So in Elixir, when we are bootstrapping things, we use just the Phoenix generator. You guys probably used to see this. So yeah, we define the path of our application, we define our app, our main module name. We set up our database, like Postgres database with Ecto, and then this last line is just to say, okay, I don't want any assets into my application. I don't want any mailer. Just want a simple API and nothing more. So yes, we could run our server in development or just our server in a standalone mode. So yes, we would end up with something like this, where we have, as you know, a clear separation between what it is web related and what not, like our business logic here. So this is the entry point for our program. And yeah, we also have the config folder where we set all the environment dependent code configurations in this case, and we have the pre folder where we have all the database migrations, for example. But yeah, I think that's it. And well, the first comparison of this evening, it's like this one. So yeah, regarding project structure, I think Elixir and Phoenix are kind of opinionated. I don't know if I should use this word here, but yeah, they ship with Ecto by default, which is a great thing. For example, we have a very specific structure that you might not want to follow, and there's no enforcement on that. But yeah, the community tends to follow this structure. So almost every project I see uses this MVC kind of structure. So there's kind of a community alignment here, which is cool. On the other hand, we have our Node and Fastify project, which is more liberal here and delegates the responsibility of structuring things in our way. This could be nice or not, and if you work with people that don't follow good practices or don't know what good practices are, you will suffer, believe me. Yeah, another thing is that the Fastify project don't have like any database setup. We need to do one by ourselves. We need to decide what ORM we want to use. We need to decide our database, and yeah, so there's a lot of space for us to just make some mistakes here. So yeah, so our first assignment, fetching data from a remote service. We have all set up, so I don't have any adapter, unfortunately. But yeah, the requirements here are pretty straightforward. We needed to be authenticated to make requests. We needed to fetch all our organization resources from that remote service, and we need to serve these organizations to our clients. Well, we have an API specification, very easy one, like organization list to get all the metadata for all organizations. Then we have this organization ID to get the specific organization data. And that's only it. That's only the things that we need. And yes, we have a rate limit of 10 requests per second. And after playing with this API, I found out that there is also a concurrent rate limit in this remote service, which is a pain in the ass, really. Yeah, so our meta solution would be something like this, like login into the service to get the authorization token. Then we get the list of organizations. Then we split this list into groups of the size of the rate limit. Makes sense. And then for each group of organizations, we simply get the organization-specific data. We wait a second to not break the rate limit. And we continue to the next group. And finally, we store data. And I think that's a simple algorithm to solve this issue. So let's code. Let's see how we could do this in Node and and then Elixir. So well, can you see it back there? No, I can just. But it is the highlighting or the size of. Not great, but you can see it like this. So okay, I'm trying to highlight the first line here. So okay, yeah, I would just wanted to say here that I want to create like a script here in this path. I think that is a good way of structuring our code. And then yeah, we could get the credentials from our system because they're secrets, so they shouldn't be hard coded anywhere. And finally, we set the base API URL. So we could start with this. Thing is, this remote service also has a sandbox environment for testing, which is kind of cool. So what we do here is like, depending on our environment, we could use the production URL or just the testing URL. But from someone coming from Elixir, and I think this gives me a lot of itches because we shouldn't have environment-dependent code into our business logic, right? By the way, this is something that I see quite frequently in code bases, which kind of pisses me off. So what about in Elixir? How can we do this in Elixir, or how could we solve this? So I think we could solve this in the config folder. Like we have our base configuration, we have the dev configuration, the production configuration, and test configuration that are configurations that are set in before compiling the project. And then we have the runtime configuration, which is loaded by the application after compilation and before we're running the app. So I think this is the right place to hide our secrets, right? So yeah, we should do it like this. We could create a URL under a remote service key into our app, in our base configuration. Then we could like overwrite this configuration for production, and then in the runtime configuration, we could get all the credentials from our environment. Simple thing. Then we could turn all of this into a module attribute that is set in compile time using just the right environment. So I think this is really cool to do in Elixir. So which led me to think, how should I try to do something like this in Node? So is it possible? And it kind of does. So yeah, it is. So we could create like a base configuration, a base object configuration under config, something like config ex. We will create an object with these properties, and then in production we kind of could use the same thing. We overwrite the base API property, and yeah, for type safety, we could say that the production configuration follows the type of the base configuration here, but because we are trying to extend it, then yeah, we could use this partial here, which is kind of cool. Then we'll have our entry model for configurations that will import all the configurations, and we could have like this if here where we set the right configuration depending on the environment that we are. So we are extending the base configuration with the right environment configuration. So we could turn this into this. I know it's just a line of code, but in my opinion, this really better than what we have before. So yes, kind of great success here. So by bringing this Phoenix configuration concept into our Node app, we were able to achieve this cool thing. So continuing our implementation here, we kind of can create an instance of Axios, which is our HTTP client. And then, yes, we could set up an initial configuration with a base API, a URL with our headers and some validations here. And then we could use it to do our first function, which is the login. Then we just log in, we just post into the remote service, we just type the response we want to receive, and we destructure this response. If we have an access token when this finishes. Then we return it. Otherwise, we just throw a new error like we failed to log in. So pretty simple. We can do this for getting the organizations list. What is different here is that we have an authorization and a different response, and the same for get organization by ID. Basically, same thing. So how could we do this in Elixir? I think this is also pretty simple. We could use HTTP poison, or you can trash me because I use HTTP poison. We can extend the base behavior here, and this means that we just need to implement some callbacks here, which are basically functions that process our request and our response. And yes, here we just process our request body, which just encodes it, and then we can decode it in our process response body. Yeah, pretty simple. We can do this. We can do a login like this one. This is pretty simple. And then the other two functions with the authorization, which are really simple. Then in our organizations model, which is where we set our flow of things, yeah, we kind of need to alias this API. We get the credentials from our environment. We try to log in. If we get a successful response, then we will get the access token. Otherwise, we will just stop the process and fail normally with this reason, which is a login failed. So we could do the same for the other two functions. Just repeated code, I think. No big differences there. But back to our login in Elixir. I just wanted to say this wasn't an innocent line of code. When we can't log in, then we can't follow the rest of our flow, the rest of our execution path, the rest of our algorithm. So we stop here, we stop the process, we exit normally with this reason. And what is happening here is that our organization's process is just failing, and our supervisor will receive the notification or the message in this case, because it's BIM, it's a message. Sorry. So we want to delegate this recovery process, this recovery process to our supervisor, which kind of makes sense here. So yeah, whatever we want to do next is up to the supervisor. We want to restart the flow right away. Do we want to have some strategy with the exponential backoff or other things? Yeah, I think this is the idea behind this fail fast, let it crash philosophy. If something unexpected happens, then the best thing is to let the exception happen without rescuing it. Therefore, like if this fails, then only the supervisor will be notified, and the other processes in our app will continue to execute. And all of this is isolated. So this fail is isolated from the rest of the app, which is kind of great. In Node, this is a little bit different. If we look at our login, the thing that we are doing is if we don't have an access token, then we just log this into our console and throw an error. And yeah, when we are doing TypeScript and Node, we need to consider two things when we are dealing with errors, which is how to deliver errors and how to handle errors. And these are two different things. To deliver errors, we could, for example, throw errors like we did in our login function. We could use callbacks, which are not cool things, at least for me, where we have this function with a callback and we just call it with either the error or the result, or using promises where we could resolve correctly or reject, or using an event emitter to send notifications of events that happened, and hoping someone is listening for them. So this is the four ways that we could deliver errors. Then for handling them, we could try catch finally pattern, where we define behaviors and different flows of operations for each case. We could try to use a middleware. For example, in Fastify, we can plug an error handling function into Fastify, and if something happens during our request lifecycle, if some error is thrown or something like this, we can catch that error and handle it there. It's kind of isolated, so I think this is a good way of handling errors in Node. And then at the topmost level of our apps, we could have like a listener to auth all the unauth exceptions, or a listener for all unhandled promise rejections. And I think that normally what I see is, I see this in almost every project that I look at. And when both of these things happen, the normal behavior for Node apps is to just fail and crash, and then we restart it manually. And we can, the thing here is that if we do that, we are compromising our availability, right? If we don't have an app running, then we can serve requests, then we don't have availability. That's basically it. And the other thing is that, are we failing into an erroneous state because we didn't handle things correctly? Is our app behaving badly because of an incorrect state? I think we could get into these kinds of things really easily, in my opinion, of course, where we don't have like a supervision tree or an easy structural way of stopping the error propagation graciously, right? So it's kind of bad, in my opinion. And we need to take really good care of these aspects in our applications, because they could have a great impact both for good and for bad. Yeah. But yeah, back to our example and testing things out. When we have this thing in Elixir, when we are coding these things, we want to test it manually. We want to test if our login is working. And the way we do this is with EX, of course. We just go into our shell and we just do this, and we get login and we say, yeah, we are logged in the system. Thing is if you want to automate this, we could just write some things in our IEX file, right, where we just automate this by, instead of writing all of this, we just alias to orgs, or we can import the login function into our interactive shell, or even executing some code after we entering the interactive shell. So if we have this file and we start the project, we would have a response like this one, like the login thing before, right after entering the shell, or the orgs login, or just using the imported login, which is kind of cool. Great success. And in Node we have this. So how can we test this? And I kind of have headaches with this. We have the REPL, which is kind of our interactive Elixir shell, but for Node, which is not great, unfortunately. So we could run something like this, and if we want to run our login, we need to import all of this thing. We need to write all of this, and then we just run the function, and we see that we are logged in. And yeah, if we repeat this constantly and we don't have a reply history, this could be tedious, right? Which led me to think if we could have something like IEX, but for Node. And the direct response is nope, we can't. But we can work around this. So I'll show you my solution for this. So this use script here, which is the REPL-TS. This is kind of a way of running asynchronous code at the topmost level of a TypeScript module. Yeah, and Node offers this native implementation of the REPL that we can use and abuse to get things a little bit more customized and automated. So we could just customize our prompt here. Then one way to, if something bad happens, we listen for this event and we just exit, one way of handling errors. Or if we want to set up an history and something goes really bad, we can just reject a promise, and another way of handling errors, two different ways here. And after this, I can just import my module right into the server or the REPL context, and then I could end up with something like this, which is better than we had, but is not IEX. So I think we have a great success here, or kind of. But yes, I tried to. Back to our solution. We have these three in Elixir. At least we had these three functions. Then we just need to write the flow. We need to log in into our service. We need to get the organization's list. We need to get the organization's data, and we need to cache it. So let's see this function where the magic happens. So we take our organizations, we split it into chunks of the rate limit size. And then we do this, which is basically we are saying the task supervisor that, okay, take this chunk of organizations, and for each organization in this chunk, you will get the organization by ID, and you will have this max concurrency limit, and we don't care about our order. And yeah, I think like visualizing what is happening is like we say this to our supervisor. It will create 10 tasks in a row, but it will start only 5 of them. And when some task finishes, it will start another one, and so on until all the tasks are finished. And I think the cool thing about this is that the supervisor will ensure that no more than 5 tasks will be running simultaneously. And this could come in handy to go around that concurrency request limit that we have, right? So we could have like an array of 10 elements, but only 5 running simultaneously. I think this is great. Thing is, what if this block of code runs more quickly than we thought? What if this runs under a second? What will happen? So we will process this and we'll go to another chunk, right? So we will break our rate limit very quickly this way. So we need just a little trick here where we say, okay, we spawn a task that will sleep for our rate limit interval. Then we execute all the thing that I just showed, and we await for that task to finish, right? And that's it. I think if our requests are too quick to finish, then we reach this line and we await the remaining time. And if these operations take too long, then there's no problem, because when we reach this line of code, then we already be finished and we can go to the next chunk without breaking the rate limit. So this is kind of it. We are fetching organizations. We are doing the cool thing. What about Node? How can we do this in Node? Same thing, same flow. We log in to get the access token. We get the list of organizations, and then we get the organization's data. And this is it. That's our solution. We just do the same as we did in Elixir. We get the chunks of data here, and then for each chunk of data, we will wait for 2 promises here. The first one, we will get the organizations in this chunk, which is this function right here, where we'll get the organization by ID, and the other one is just sleeping, like the trick that we did in Elixir. And yes, when this finishes, we go to the next chunk. So this should be the solution for Node. The thing is that this is not a solution. This not runs. This breaks the rate limits. And why? Because our map is asynchronous. Yeah. This thing here, and the map is asynchronous because we have a transformer that is asynchronous. So what Node does is that it will try to execute all of these chunks asynchronously. So this is kind of bad here. Map is asynchronous, and when we come from Elixir, where our maps are synchronous and we know what we can expect from running a map, this is bad. So the solution here is just a simple for. Like, yeah, we don't like fors, but this is a solution because for loops are synchronous, right? So this way we can run this block of code here, and then only when this is finished, we can go to the next chunk and do exactly the same. And the tip that I want to pass here is that when your code aims to be concurrent and synchronous, like in Elixir, you're formatted to think that your program is a set of execution of operations that will execute synchronously, right? So if you want some asynchronous code, you will spawn some tasks and you will wait for their termination. That's it. In asynchronous code, this is kind of different. You have a bunch of promises and asynchronous code, and you want to write code that reacts to an event of completion. And when coming from Elixir and TypeScript, this is weird, at least, and you feel that in your skin. Yeah, but another success. And lastly, caching data. In Elixir, we could do this with ETS, of course. We will cache this in memory, by the way. We could do this with ETS, but I will show you how to do this with agents, which is basically like spawning a process and say you will be handling this state, and this process could receive messages and reply very beamish here. And this is a way of keeping data in memory. So pretty simple, right? We delegate that to an isolated process. And in Node, this is kind of different. We could do it with global variables in our module, like we are using them throughout our algorithm. Like this access token is a global thing. That's why we aren't pass it as an argument. And yeah, the model itself keeps values in memory, so we can access those values either by exporting them or with a getter, for example. And if you're coming from OOP, I think you can look at these modules like singleton objects, where you have one instance of this module and you can interact with it, with its memory and its state, of course. Obviously, if you know what you're doing, you could do a lot of shit if you don't know how to use this. And yeah, concluding this tiny example, I just wanted to highlight some things that I mentioned during this talk that I think that are really good in Elixir. I think that having like an opinionated project structure from the beginning and the community in line and following those standards are really cool. And if you're looking at other projects, you will see that people follows those standards, which is cool. The config philosophy, which we imported to our Node project, the fail fast, let it crash. I think this is a no-brainer, really cool, which has an impact on our fault tolerance and availability in our programs, and our interactive shell in steroids, which does a lot of things, a lot of cool things. And yeah, it is concurrent and synchronous code, which I think is logical, at least more logical for people. But yeah, and many more things that I didn't mention in this talk, and these aren't not kind of the 13 reasons why, but yeah, these are the reasons why I keep thinking about Elixir when I'm coding Node. So yeah, that's it. I think it's time for questions, or if you prefer, you can talk while eating something. Yeah, that's it. Of course.
I have something, another question. Because you showed the agent, the caching, and how you would do it in Node. in a node you might have like a global variable where you store the values. Like with an agent, you can just spin up 100 agents and they all have their own state, right?
Yep.
This would just be a single one.
If
you spin it twice, it would overrun each other.
Yeah, of course. That's a thing. But for our tiny example, this works, and it's a good way, or an easy way at least, of doing it. But yeah, with agents, it's a lot cooler. And with ETS, we have a lot of more features into it. So yeah.
That's by files, right? So if I just dynamically create 100 files, that might work too.
Yeah, if you could import those 100 files, yeah. Yeah. Of course, why not?